What's at the edge of the universe? Does the universe even have an edge? Hi guys, this is going to be interesting, very intriguing, and difficult, but I'll make it simple. At least I'll try. Have you ever wondered, where does the universe finish? What's at its edge? How does its edge even look like? If we could look at it, it's too far if it does have an edge, but if we could look at it, what would it be? This question implies so many other concepts. Let's proceed in logical order. What's at the edge of the universe? I put a big question mark, sorry, because it's a very mind-bending concept, and we will see why. We can try to wrap our mind around it, at least partially. So there are plenty of documents, articles, videos about certain things that we already know. That's why I wanted to try to address the things we don't know yet. And feel free to express your opinion, your comments, your help to contribute. So let's start. What's at the edge of the universe? I have my outline here because it's a very difficult and convoluted topic. We usually take space itself for granted. What do I mean with space? I don't mean the space like the universe, like usually stars, galaxies. I mean space itself, the fact that there's room. For a second, let's pretend there was nothing. No stars, no planets, no galaxy, no dark matter, no nebula, gas, nothing. The universe was empty. It's a kind of absurdity, but let's pretend. Still, if magically something were to appear, a starship or a roaming rogue planet, and just traveling around, there would still be room to go. It wouldn't hit a wall or a kind of a street sign saying, sorry, road finishes it here, you can't go further. Well, then what's beyond? So we usually tend, to take space for granted. Our minds are so used to space, to speciality, I don't know even how to pronounce it in English, sorry, to reality, to the fact that there is space and time, we will see, that we don't think about it. We take it for granted. But what space is, I'm not talking about anything that soaks space, whether it's light, energy, EM waves, gas, anything. No, I'm talking about the fact that there's space. What is it? It's not nothing. We are used to think that it's nothing because we don't see anything. We put our hand, our arms, or we throw a rock, or a planet goes through this thing, that we are used to subconsciously think about it as nothingness, but it's not. It's something. Yes, there is the quantum theory about saying that emptiness, it's not empty, but it's soaked in virtual pairs of particle and antiparticle continuously appearing, annihilating, and so disappearing again continuously. But we already know that. What is it exactly? Why isn't there nothing? Because if space is not nothing, if there was nothing, we couldn't even go there, whether it's a meter from here or 100 meters or a light year. Nothing could even go, a planet, a pen, an atom, nothing could go anywhere if there was absolute nothingness. If the empty space was nothing at all, was the absolute nothingness, if anything, another absurdity, could even jump there somehow, it would instantaneously cease to exist because, let's say this pen, it would have jumped into nothingness. So it would have simply ceased to exist. So empty space is empty, if possible, but it's still something. It's an object somehow. It is reality. And it allows anything else to exist. So what is it? Because we need to clarify these. We need to be aware of these of this thing to be able to talk about its edges. If we don't even identify it, how can we talk about its edges? We talk about the edges of this country, we need to know what we're talking about. So in this case, we're talking about Canada, for example. Okay, now we identified Canadian's border. So what is it exactly? Of course, space is not only space. We know already that it's space and time, commonly defined as space-time. We can already see how we are expanding its edges, not only somewhere in space, but also somewhere in time. So what's the edge of space exactly? What's it made of? How does it look like? Let's pretend that nothing was in the way between us and the edge of the universe, so that we could see through it, through the entire distance that separates us. But there's still problems, because what do we mean exactly with the edge of the universe? But let's pretend that it was empty, nothing was in the way, and we were to look at the edge from our point of view. What would we see? We cannot see, as I explained in the previous video about the origin of time, we cannot see beyond the limit of the speed of light. So because to see, we need light. So we need that light or any other electromagnetic wave, so even not visible light, I don't know, like for example, infrared light or ultraviolet or other rays, electromagnetic waves, hit the thing we're trying to observe. In this case, let's say this whiteboard. So we need light to hit it and come back to our eyes or to our instruments. So by observing these rays, these electromagnetic waves that come back, that's when we see what was here the moment that ray left the whiteboard. So the moment the ray leaves the whiteboard, it carries with it that kind of information of how the whiteboard looks like. It gets here on our eyes or on our instrument, and we see that information in form of EM wave, light in this case. Or, so either something passively illuminates it, so the light goes there, bounces back and reaches us, or it directly emits light, like a light bulb or a star. It directly emits light and we see it when it gets to our eyes or our instruments. So what about the edge of the universe? We cannot observe in any given moment beyond the limit of the speed of light. Then how comes we can see galaxies and stars that are billions of light years away? Well, because their light started that journey long time ago. But let's pretend nothing was in the way. Right now, up to what distance we could see, what would we see? We would see absolute darkness, it seems to me. Not only because there is no star or no other sources source, sorry, of light or any other electromagnetic wave, but also because simply we cannot see beyond. Let's pretend we could turn on a light torch and illuminate, let's say, the edge of the universe. So the light, let's say if I illuminate this piece of wood, the light starts from my light torch, it gets here, bounces back and comes back to my eyes. That's what I see. I see this wood because light is coming back. But let's pretend that this piece of wood, this whiteboard, instead of being the whiteboard or the wood, it was the limit where light can get in any given moment. So light would simply be unable to come back. Does this remind you of anything? The light cannot come back. Black holes, light cannot leave their surface. But anyway, so let's redraw our little miniature of the universe. Okay, this is us, meaning our planet, our home, our window, our point of view, our frame of reference. This is the limit of the observable universe. Now, the observable universe is carrying information since a long time, so it's dozens of billions of light years extensive in its extension, sorry. But there's also the light cone that I explained in the other video about the edge of time. So basically, in any given moment, we can only influence the rest of the universe, of reality, in a radius of, let's say in any given second, 300,000 almost kilometers, because that's the speed of light. That's the most we can influence. By, for example, turning on a light source or a laser, in 1 second it would cover 300,000 kilometers. That's the longest distance we can cause some kind of physical influence in the universe in reality. Because going beyond, influencing beyond, for example, illuminating beyond that, it would mean to have some kind of light or energy or tool or effect or bullet or something faster than light, which means that in 1 second it would cover more than 300,000 kilometers, which is impossible physically. So this is us. This is the radius the light can cover in 1 second, 300,000 kilometers. If it was in 2 seconds, it would have been double, 600,000 kilometers, and so on. What's here? Well, there is something. The fact that we cannot influence there, it doesn't mean that there is nothing. But it's not that simple. Let's see why. So, let's forget the observable universe for a moment, because that's light and information that's traveling toward us since a long time. Let's consider the edge of the universe that we can influence in any given moment under the limits of the speed of light. Let's pretend there was nothing at all between us and that edge. So, it's not only about vision, about visibility. It's also about relative statuses. What's the status of something relative to something else? We saw in the previous video about the origin of time that the now moment, exactly now, the present moment, is not the same for different things whether it's a planet or even a whole galaxy or a single atom or a speck of dust in the universe floating around, it's not the same the now moment for anything in the universe, because it depends by the gravity they're soaked in, because the stronger gravitational field, the slower the time flows for everything that is in that gravitational field, depending by their speed, because the faster something moves compared with us, the slower the time of that thing is experiencing, is living. So basically, if an object is moving faster than us, it is existing for less time than us. And also the distance from us. This was something that I was surprised. I will put again in the description of this video too, as I did in the previous video about the origin of time, the link to a video in which at a certain point, I think after minute 18, I will write it in the description, scientist Brian Greene explains very nicely that it's not only about speed. If something right here beside me is moving very slowly, like this pen is moving very slowly compared with my other hand, okay? So the temporal difference, the difference in the speed time is flowing for this marker compared with my other hand is almost nothing. To make the difference in time, called also time dilation, huge, I should move this marker almost close to the speed of light in order to make the difference in time very relevant compared with my other hand that is standing still. But this is very important. Compared with, for the marker itself, nothing would change. If it could feel time, it would feel time as normally, like everything else, like everyday life. It's against my time that I'm standing still, that its time is flowing more slowly. So, but as Brian Greene explains, if this object was very far away in the universe from me, in a very distant point, even a very slow motion of this thing would make the difference in time against me huge. So you can watch the other video, the video of Brian Greene, and or my previous video about the origin of time, to show the difference in the now moment. So what influences time? Speed, gravity, distance from another thing against which we are comparing the two now moments. So proximity or distance. What does it mean? That if something is right beside of us, or even where the moon is, it doesn't matter how fast it's moving, our now moment is almost the same. It must approach the speed of light to have a huge difference in time. But if something is very distant from us, let's say this is time and this is space. We are here and something is here. So this is the now moment, 2018, May the 11th, whatever time, 3:54 p.m. The now moment is the same for me here and for somebody in the neighborhood right now. But if this guy gets in a remote region of the universe and it's standing still like me, let's pretend our relative speed with each other is exactly the same, our now moment is the same. We are both in the present, in the same present time. May 11th, 2018, let's say. 2018, let's make it simple. As soon as this guy starts to move, even very slowly, just going for a walk on another planet in another galaxy, very slowly, his now moment gets a little shifted to the past compared with my now moment. So instead of being straight towards 2018, it goes a little bit towards the past. Not much, because it's not going fast, just a little bit. But because of the distance, of the huge distance, see, if I was here, very close to it, the difference in time would have been minimal. But because we are very far, you can see how the difference in time gets amplified. So as soon as this guy starts to walk away from me, the now moment that for me is now gets pushed into my past, into our past. So this guy ceases to exist now, but goes back maybe in 1918, 100 years ago from now. So the now moment for him is our long lost past. So we can see how in the universe the location, the space-time location, the space and temporal coordinates of anything compared with anything else is a relative status. It's not absolute, static, like a photograph. So what influences the relative status of things? As I said, speed, gravity, and distance. Also direction, because if this guy stops walking away and starts walking towards our galaxy, its now moment gets pushed into the future rather than into the past. So again, right now it starts walking toward us, boom, it's gone. He's in the future. He's not in the present anymore. He's in the future, in our future. If we were very close to him, 100 meters, 100 kilometers, it was maybe in the future 1/1,000,000,000th of a second. But because we are so far, maybe he's in our future now, 100 years from now. So, relative statuses. So let's go back to our simple scheme and let's try to get to a conclusion, to a first conclusion. Okay. So, if this is us, our location, and this is the edge in the universe that we can observe or that we can have physical influence of some sort, for somebody that is here, its own edge is this one. It's not the same as us. So we can see that there is a portion that is beyond our reach, but it's within its reach, at least of light. So as we can see, the edge of the universe moves with us. It's like moving this whole thing. It follows us. So how are these different frames, these different domains, environments of reality managed? There must be some kind of object of singularity, we can use this word to name it, that manage both the areas, even though these two areas are beyond the reach of light. This is incredible, because it means that this thing that manages both the areas and keeps them properly, lubricated, in working order, and it doesn't, and the universe doesn't go nuts all of a sudden. This thing that manages these two things is beyond the limit of the speed of light. If you see If you check the other video, previous video I recorded about the origin of time, you will see that we're talking about a timeless thing. Necessarily. In that video I explain why it should necessarily be timeless from the temporal point of view, the origin of time. Here we're talking about the space. So this thing should also be spaceless, and we will see why in more detail. Spaceless. Now this would act as this, let's say, metaphorically speaking, the scaffold of the universe, the scaffold of reality. Remember when I said 10 minutes ago that we tend to take space itself, the availability of space, for granted. We tend to subconsciously conceive it, think about it as nothingness, but it's not, it's still something. Let's pretend metaphorically, again, like an analogy, that it was some kind of a piece of cloth, like a cloak, like a mantle, okay? So it's not nothing, it is something. So who holds this cloth, this mantle, this cloak? The scaffold. That's what allows it to exist and not to fall into absolute nothingness, and allowed it to pop in existence from in the first time, in the first moment, in the first place. So if this is space-time, reality, whatever, with all its characteristics and specifications, let's use an analogy. Actually, it's even better, because sometimes it's better if I draw a house, because sometimes the geometrical figures that are commonly used to represent these things are kind of misleading, because we are unable to draw quadridimensional things, something that has 3 dimensions in space plus 1 dimension in time. So we would need a whiteboard that is, among question marks, outside of reality, to draw reality properly and fully, completely. So usually there are some kind of representations, but then our mind gets too attached to it, and it misleads us. So let's simply use something completely different, just as a pure metaphor. Maybe it helps us, because we don't get attached to that design. We just use it as a ramp to jump with our mind beyond the limits of the universe and of reality. Let's draw a house. So if this house, with the nice windows, with a door, it's a little distorted, okay, this house is reality, space-time, the universe. That spaceless and timeless thing, or singularity, that handles it all and manages everything that happens, we can represent it as the scaffold, the hidden, invisible foundations of reality. So let's draw these reinforced concrete pillars that go underground, under the ground of reality. This is a metaphor. So we are talking about this, the scaffold of reality. So if what's beyond, metaphorically speaking, space and time is spaceless and timeless, of course, what's at the edge of reality, of the universe? We saw what influences the relative statuses of things in the universe, which is speed, gravity, distance, and direction of motions. Now, this is a kind of a proposal, a hypothesis, something I didn't find in the things that we already know. What I'm going to say right now. Again, as the limit to which we can have any physical influence. Let's say the limit of the speed of light in any given moment. So this is the proposal and the opinion and the hypothesis. Since in order for us to get here, for example, or here, we would have to cross the speed of light to travel faster than light, maybe, and I'm asking the opinion of educated people, physicists, mathematicians, cosmologists, maybe because the universe also consists in the relative statuses, not only in an absolute status, but also in the relative status of anything relative to anything else, status that is affected by speed, distance, direction, and gravity. Maybe because to get here or here we would have to travel faster than light, maybe this point of the universe, or this point of the universe, of reality, relative to us, this is important to remember, relative to us is, where is it? Or even better, how is it? Maybe relative to us is in the same place, or in the same time, or both, or in the same status as we would be if we traveled faster than light. So what would happen to us if we traveled faster than light? Okay, it's impossible physically, but let's make a thought experiment. Do we know what would happen to us if we traveled faster than light? Well, I'm not a physicist, but I saw a lot of answers answered by actual physicists, PhDs, to similar questions. And for what I saw, it seems to me that it's not perfectly clear, but I could draw an almost universal consent trend in their answers, that if we or anything were to travel faster than light, it would at least stop its time relative to us, relative to whatever else it's traveling faster than light. So if, let's say, our planet is here, a guy is here perfectly still, this thing leaves and then passes the speed of light relative to the guy that is still, at least its time would stop. Some people says it would go back in time. If you check my other video about the origin of time, probably how far, among question marks, if it was possible to define temporal coordinates in time, how far that thing that magically, let's say, accelerated past the speed of light against us, how far in past would it get? A hypothesis I proposed in that video is back to the origin of time, all the way back to the origin of time. So if this is the limit of the speed of light relative to us in any given moment, what's here? What's here? The very same origin of the universe, both as space and time. So using the usual graph, the usual chart, how the entire history of the universe is kind of represented on a piece of paper, which is origin of time, Big Bang, expansion of the universe. So time and space, time and space, expansion of the universe because it grows in its size, and then over time. Okay, so all the way here, the origin of time. As we saw in the other video, we cannot say before time, because time signs the moments. So there's no before of time. So as we saw in the other video, we cannot say before time. Before time, there is nothing. There's no time, nothing temporally speaking, but there is something absolutely speaking. Otherwise, there couldn't even have been time that started. We called it timeless thing. I represented it as a green because it was the only other color available, because I used yellow and red for other things, as a green blob that I called a timeless thing, timeless blob. Let's call it initial singularity, like sometimes scientists call it. Initial singularity. So, because to get here or here beyond the limit of the speed of light in any given moment, we would need to cross the speed of light, to overcome the speed of light. Maybe relative to us in any given moment, this part of the universe, and whatever it contains, where is it, or when is it, or how is it, it kind of, metaphorically speaking, resides, it is located in the origin of time. What does it mean? It doesn't exist. It means that it doesn't exist yet. If something very far away from us starts to travel at a certain speed, its now moment goes back in our past 1 year. It gets farther away 10 years, 100 years, 1,000,000,000 years. It goes back and back and back up to the origin of time because of the extreme distance that goes beyond the reaches of the speed of light. What does it mean? Back to the very first instant of the history of the universe, and even before that, it means it doesn't exist yet. It does not exist yet. So what does it mean? That probably we shouldn't ask where is the edge of the universe for us or for any other thing in any other point of the universe. Maybe we should ask, when is it? And when is it? We can use an analogy with the waterfalls. This is a beautiful analogy that helps a lot, in my opinion. Hopefully it's not misleading like other analogies. So, let's say that, if this is a river and the water flowing in this direction, metaphorically, the river represents the entire universe in any given moment. Now, the present moment. Yes, the now moment is different for everybody, but let's simplify. So let's say that this river is a little messed up, but let's simplify. If we ask where is the edge of the universe, where does it finish? We are asking the wrong question. Maybe we should ask when, as I said. What does it mean? It's meaning that it's a different level. It means different level, past. It's not here at all. It's nowhere. The edge of the universe goes beyond the limit of the speed of light that, let's say, is here. See, it gets the waterfall, it falls. It's not on the same level anymore. Here, there is nothing. There's no river here. If the river is space, there's no space here, which means there's nothing. It doesn't exist. It goes down, back in the past, in a different level. So the edge of the universe, it's not a wall that if we get there, we hit it and we touch it. The edge of the universe doesn't exist because it's in the past. And the edge of the universe represents the beyond light, let's say, limit in any given moment for anything beyond the limit of the speed of light, which is in the origin of the universe, which means it doesn't exist yet. It's as if it it would still to be created. It doesn't exist yet. So now, another important concept why it is. If we take a 2D, a bidimensional, two-dimensional figure or object or thing, let's say a circle, if we want to identify its edges, we have to consider both the two dimensions that it has. Because if we consider only one dimension, we could never really identify its edges fully. So we would only be able to identify one point, and we would try with our mind to fit the entire two-dimensional edge into a one-dimensional point, and it doesn't fit because it's not real. So we have to consider two dimensions to fully identify the edges of the circle. If we have a three-dimensional object, a sphere, it's the same. Let's say a sphere. We cannot consider its edges fully if not in three dimensions. Why? Because it has three dimensions. So if we considered its edges only bidimensionally, we would only be considering one circle, one circumference, like one slice of this sphere. So like literally one slice, but it's a sphere. So we would try to fit its entire surface, its entire edges in a two-dimensional circle, and it doesn't fit. What about the universe? The universe has three spatial dimensions and time. So kind of 4D. So if we want to consider the edges of the universe fully, in its entirety, maybe we need to consider time too. So we have to consider the entire universe in the entire time. And now it's getting tricky because there is a booby trap in this. And sometimes I saw videos and it seems to me that those videos fall into this booby trap. And let's see why. So we have to consider the entire space in its three dimension in the entire time, past, present, future. So it's useless that we try to figure this sphere in 4 dimensions, like in the entire time. It's impossible, so let's not even try. So remember the waterfall? See, we are not only considering space in its extension, but also time. It's in another level. So I'm sorry, this is very complex, and I have my notes, my outline, and it's difficult to remember all the hints, and I need to have a look every once in a while. Okay, so let's go back there again. So what would happen if we fell in a black hole? Again, we don't know, scientists don't know for sure, but seeing many answers of many physicists to similar questions, I could kind of draw a common trend in their answers. Again, our time would stop relative to the time of the rest of the universe, or whoever and whatever is outside of that given black hole, or we would be pushed back in time. In my opinion, we would get back to the origin of time. In my opinion, the initial singularity that kick-started time is the very same thing as the singularity that opens up in a black hole. But that's my opinion. It's not a similar thing. It's the very same thing, because two different objects in the universe or in reality can have two different times, can exist in two different times relative to each other. So we go back 1 year, 2 years, 10 years, 100 years, or in the future. But if we go back at the origin of time, before time, kind of before, as I explained in the other video, it's even, we don't have a vocabulary to describe things that transcend time. So let's say in the initial singularity, which is timeless, so that thing still, again in question mark, exists. We will see why. So again, as in any given moment, the speed of light limit in any given moment, beyond. Let's recap 1 second. As I said a few seconds, because to reach here in any given moment, we would have to travel faster than light. Maybe right now, this point of reality of the universe is where we would end up, or when we would end up, when, remember the metaphor, the analogy of the waterfall in a different time, if we were to travel faster than light. So, similar to what happens if we fall in a black hole. So probably, let's try to answer with a hypothesis to the question I asked in the beginning of the video. If nothing was in the way, and let's say I was able to observe this edge, what would we see? Now, it is impossible. Why? Well, because this edge always follows us. So if we move here, it's here. If we move here, it's here. So we can never stop the edge and jump here. Again, we would have to jump faster than light. But let's say, as a thought experiment, if I could find myself 10 meters before the edge instantaneously, and then again instantaneously turn on a light torch or a laser and point it to the edge, what would I see? As I said before, hypothesis. Because beyond the edge right now, it means beyond the speed of light, maybe I would see, and because by overcoming the speed of light, something similar to us would happen as if we were to fall in the singularity of a black hole. Maybe if it was possible for us to immediately observe that edge of reality, we would see the same thing that we would see at the black hole, a black wall. So absolute nothing, pure blackness. But black not because it's simply empty space. It's a completely different monster. We would be watching back in time. But again, because the origin of time, I mean, that thing, it doesn't exist yet because it's before, it doesn't exist yet. So we would be seeing anything. We wouldn't see anything. We would see nothing. So it's very difficult. In the concepts, when these concepts come in mind, it's much more clear, but translating it into words, I'm sorry, that's the best I can do. So I'm going through my notes again, sorry. If we want to consider the edges of a circle, we have to consider all its dimensions. If we want to consider the edges of the universe, we have to consider space and time as a whole. Where is the booby trap? As I mentioned in the previous video about the origin of time, let's see the booby trap. The booby trap consists in the usual figure, geometrical figure that is used to represent the entirety of the universe in space and in time. with the Big Bang starting here, so the origin of time here, this is the direction of time. This is now, 2018, now. This is past, and this was past, and this will be future. This is the beginning of time, beginning. I'm not saying before there was blah blah blah, I'm saying there was no before. So origin of time, and beyond that, nothing, temporally speaking, but something that is timeless. The famous green blob, because they really don't have any other way to represent. So origin of time, boom, explore, kind of explosion, Big Bang. So expansion, so time and space, space and time, expansion of space in all the directions over time. So expansion, and then there's the bread loaf, shape of the universe. So those videos say that if our now moment is in 2018, and the now moment, for example, of an alien walking, or of a planet moving very distant from us, the now moment, because it's moving away from us, is not the same. So it's not in 2018, but it's pushed towards the past. Okay, so let's say 2018, 1018 in our past. So this thing, for the very fact that locally is localized far away from us, and that it's moving far away from us in space, for that very fact, it, boom, it's gone. It's not in our present now 2018 moment anymore, but it's in our past. If it's moving towards us, it's not now, it's gone in the future. It's in our future. Right now for us, it's in the future. So these videos say that past, present, and future all exist already. So basically what they're saying, that we have a series of slices, temporal slices, like many frames of an old film on a film, and that all time exists now. The past, the present, of course, and the future. So it's kind of what I was saying before, that if we want to consider the edges, the limits of the entire universe, because the universe not only has 3 dimensions but also has time, we have to consider the entire space in the entire time. So from this point of view, they're right. From what other point of view, what other aspects, it's a little misleading in my opinion, on the contrary, which I consider a booby trap because it's misleading, is the use of the present conjugation of verbs, the use of now. If I say that the past still exists, by saying still, I mean now. I am pulling the past into the present, but it wouldn't be past anymore. We just said that the alien that is far away from us, if it moves far away from us, it gets pushed in our past. If I say that that past still exists now, it means that the alien's now moment, it's not in the past, but it's in now. It doesn't seem very right. If I say that the future already exists, again, I'm not talking about the future, I'm talking about the present. So I'm trying to deform, to distort the future and pulling it in the present. So, as I said in the other video about the origin of the universe, the only way to consider, to properly draw this bread loaf of the universe would be to draw it in a timeless and spaceless whiteboard. in this timeless green blob that produces time, timelessly, because it's timeless. So when did it produce time? When it caused time. Before time there wasn't time, there even wasn't anything. So if I say when did it produce time, I'm saying that in some moment in time it caused time. No, then it didn't cause time. It was trapped in time with like anything else. So timelessly produces time, not produced. Let's use a kind of an timeless present conjugation because we don't have timeless conjugations of verbs. So if we try to draw the entire universe in the entire time in its entirety on a temporal whiteboard, on anything that is in this universe that is soaked in time, including our mind, we would be misleading because we would be confusing past with present with future. So where's the booby trap? It would be the same thing as, remember when I said, if we consider the edges of a circle is a two-dimensional figure. If we try to consider the edges of a circle in a one-dimensional point, in only one dimension, we are trying to squeeze its two dimensions, so all its, let's say, one-dimensional points into a one dimension. So we wouldn't be really conceiving its edge. We wouldn't be really representing it because we would be distorting its reality, its real shape, let's say, into one dimension while it has two dimensions. We would try to fit, to squeeze its entire two-dimensional circle into a single point, but it's not. Again, the same for the sphere. If we try to describe or to conceive or to draw or to consider the sphere in its entirety, its entire three-dimensional surface, see I'm moving it in all the directions, considering only a slice of it, only two dimensions, we would be trying to squeeze, to fit a three-dimensional spherical surface into a two-dimensional circle, which doesn't fit. If that representation would be faked, wouldn't represent what it is really. It would be misleading. So the same if we represent a 4D universe, because three spatial dimensions and time, in this way, it's misleading. We are confusing the future with the present, with the past. No, the only way to properly consider the past, the present, and the future in its entirety, which is also the space in its entirety, is timelessly. We wouldn't need to have our minds working timelessly, like that green blob that not produced, but produces time, timelessly. Now, unfortunately, we are not able to reason timelessly, so it's even more hard to explain something I cannot even fully understand. So, where's the booby trap again? I'm sorry, it's complicated. When we say, see, this guy is moving far away from us, right now there are planets moving far away from us in a very distant spot. So their now moment is gone, is in our past. It's true. So from that, can we say that their past is now? No. They do not exist yet for us. Again, it's linked to the origin of time. So, sorry, it's very difficult. Let's try redrawing this in a different way. So where is it, or when is the past, which is, for example, the now moment of something that is very far away from our galaxy and that is moving far away from us? That now moment does not already or still exist, as if the past still exist. No. Where is it or when is it? Timeless, spaceless. It's in the origin of the universe. So basically, the hypothesis is that the answer to the question is it doesn't exist yet. It is yet to be caused, created, whatever. What does it mean? That slightly less misleading, because we are still trying to draw a four-dimensional universe on a two-dimensional board, but slightly less misleading chart would be this. The origin of time and the famous initial singularity, post-initial singularity, let's see, the origin of time. Not like just one thing like this that then expands, but like many. Let's say, here it is. It's kind of confusing. So, for any given thing, from an atom or a quark, or whatever is smaller, if any, to an entire planet or galaxy, for any given thing in the universe that is beyond the limit of the limit of the speed of light, relative to us, they're still here, meaning they don't exist yet. Maybe that's the hypothesis I'm proposing. So, for example, let's say galaxy named X. Right now, it's moving far away from us. Its now moment is in the past, The farther it goes, the faster it travels, the more back in time into past until it gets to that limit, boom, it doesn't exist yet. So meaning it's as if there are many different big bangs, metaphorically. Countless, trillions of big bangs. All the time. Time is being caused, produced, constantly, all the time. So if I would try to draw the universe in an even further slightly less misleading way, would be, what about the future? If something is moving towards us, well, watch the other video, The Origin of Time. At a certain point I explain as the future, the two things kind of converge, but you can see in the other video. I don't want to mess up this video more than it already is, sorry. So maybe an even slightly less misleading way to draw the universe is, if we consider the origin of time, that timeless green blob, I don't have any better way to draw a timeless and spaceless thing. I would say this is a galaxy. This is another galaxy. This is us. Something is a little in the past, a little less in the past, a little more in the past. Something that doesn't exist even yet. Something in the future, because moving towards us at a very high speed but from very far away. This is the universe. Space-time. We're trying to kind of consider space in its entirety of 3 dimensions and in its entirety of the temporal extension. It's a mess. And maybe there are shortcuts between, maybe quantum entanglement of entangled particles or wormholes, which in the theory of relativity fits in the math. And this is timeless singularity. Now, remember the scaffold, the pillar of reality of space-time of the universe that I draw in before in the I talked about, I mentioned in this video about 20 minutes ago, half an hour ago, maybe before. Oh, it's already 1 hour. Remember when I represented the reality as a house? Okay? And the scaffold, the pillars, the hidden, invisible foundation of reality, which is beyond reality. Remember when I said that this is us, and this is the limit of our cone, light cone of our observable, or the speed of light of our universe. But if something is here, this is its limit. So who's managing these? Both of them. It must be something that is beyond both, and that it's able, with its metaphorical arm, to kind of grab them both and manage them to avoid that the entire universe goes nuts. The green blob, the timeless and space. That's the only way for it to manage things that are beyond the reaches of the limit of the speed of light, to be timeless and spaceless. So see how it manages it all? And now there is another issue, another mystery of the interactions. So we have the manager, the thing, the foundation, the scaffold of the universe, spaceless and timeless, the origin of time that I mentioned and explained in the previous video about the origin of time. And then we have the managed, okay, every single different frame of reference of anything, from atoms, from quarks to entire clusters of galaxies, or even more. So we have the foundation and the sustained things. So, and then there is their interaction. So the timeless origin of time and space and Big Bang sustains the existence, like pillars, like foundations sustain a house. The only difference is that the pillars sustain the house in its physical structure, while this green blob, the initial timeless singularity, sustains the universe in terms of its existence. But how? It must interact with the atoms, with us, with the planets, with the galaxies, with the entire universe somehow, in order to sustain it and to make sure that even far reaches parts, domains of it, interacts with each other properly, and the entire universe doesn't go kaboom or nuts completely. So, like, you know, in our little context, like the sun and the earth interacts and are very well balanced. But why? Because they are within the reaches, okay, of the observable universe. But what about things that are beyond? We need necessarily something that is beyond to manage them both, okay? With my hands, so my two hands can manage and interact with each other because they are within each other's reach. With my hands, I can manage this pen, this cup, because they are within reaches of my hands. But wait a second. Other things exist beyond the reaches of my arms and hands. That wall, that wall. I'm not managing them, and yet they behave properly. The house doesn't fall, doesn't go nuts. So, in order for those two walls that are properly interacting and being managed, so the house is not falling, but I'm not managing it because they're farther from me, it means that there must be something else that is beyond both ends of my arms that is holding and allowing them to behave properly. So, the spaceless initial singularity. But how does it interact? Maybe, well, I have no idea. The only thing I can say, logically speaking, is that this interaction from its side of this timeless initial singularity, the green blob, is spaceless and timeless, is a timeless action. But from the side of the other things of the universe, it is localized in some point in space and in some point in moment. Wait a second. But that now moment its coordinates, its temporal and spatial coordinates are different for different observers moving at different speeds or existing in different gravitational fields, fields in different moments and parts of the universe, and moving in different directions toward it. Exactly. The timeless and spaceless singularity can do this and more because it's beyond time and space. It's timeless and spaceless. So it can very well sustain, hold, like the scaffold of a house, like the foundations of a house. It can very well manage even the relative coordinates, both in space and in time, of anything relative to anything else. We're talking of quadrillions of variables and of different frames of reference. You can imagine only a spaceless and timeless object can do that in any given moment. So from its side and point of view, and from what it pertains, these actions are timeless. But from the side and the point of view of anything in any moment, in any point of space and time, and of anything against relative to anything else in any moment of space and time, in any possible motion and gravitational situation and whatever, it happens temporally and spatially, space in space and in time, sorry, spatially. So this is interesting because I will use an analogy I will use a chemical concept as an analogy for this physical concept, physical reality. You know what an emulsifier is? An emulsifier is a molecule. So as you know, any given molecule can either be water soluble, or non-soluble. The water-soluble molecules are molecules that can be dissolved in water, sugar, salt, the common table salt, chloride di sodium, sodium chloride. So the non-soluble molecules are called apolar. They're non-polar. They cannot dissolve in water. Classical example, fats, oil. If you pour oil in water, it doesn't dissolve, it separates, and then it floats on top. So how would you dissolve oil in water? How would you homogeneously blend polar and non-polar molecules, substances? You need an emulsifier. An emulsifier is a kind of a double-phased molecule. It's a molecule that has one part that is polar, one part is hydrosoluble, soluble in water, and another part is non-polar, is non-soluble in water, but it's soluble in fats, for example. So if you try to mix water and oil, for example, they don't blend, they separate, but then if you add an emulsifier in enough quantity, these little molecules of emulsifier, they will grab one molecule of fat from the oil and one molecule of water. Another molecule of emulsifier will do the same thing and the same thing and the same thing. So it will allow us to homogenize oil and water in what's called an emulsion. So it's as if a molecule has two hands. One can grab water and one can grab oil or fats or whatever is not soluble in water. So it looks like there is something that emulsifies timeless actions of this timeless initial singularity and the temporal things that reside anywhere in any moment in the universe. So it's as if here we have the timeless singularity, okay, and we can use the nice green blob. Now we got used to it, right? And then we have the universe. basically space-time and whatever it contains. Okay, separated by their very different nature: timeless, time and space; spaceless, space; timeless, time. So here we have anything, everything, whether it's an atom, a quark, a planet, a galaxy, or a galaxy cluster, or the whole thing. Now this holds like a scaffold, like foundations hold a house in its entirety, even the far reaches edges of the house, because the foundations cover and hold it all, the entire building. So the timeless singularity manages and holds the existence of the entire space-time. And there is an interaction from this side, let's say, of reality. So let's call from this side the hyper reality, and from our side, our reality, the universe, space-time, reality, the real thing, the physical laws, etc., reality. Okay, so the interactions, so from the two sides, from this side, so in the hyperreality domain, the spaceless and timeless initial singularity, the action is spaceless and timeless. Let's draw it green. This is the action, timeless. It's not now, it's not yesterday, it's not tomorrow, it's timeless. Don't ask me to explain it. I can't even fully understand it. Just the concept. And from this side, we will draw it in red when the action, see, in some moment in time, some moment in space. Okay. So we need an emulsifier, something that can grab and blend a timeless action which has no origin, no coordinates in space, nor in time, and the temporal and spatial actions and phenomena. So there is like a kind of an emulsifier, a temporal and spatial emulsifier that is able to allow the interactions between something that acts spacelessly and timelessly and space-time and what's within. What is it? Who knows? If you know, please let me know. I really want to know. Maybe this lies within the quantum realm, in the quantum world, in some of those weird paradoxes, weird quantum phenomena. Maybe a glimpse of this interaction is allowed. Maybe we're allowed to glimpse little aspects of this interaction when we see craziness, paradoxes like quantum entanglement or the double slit experiment. Who knows? And so, sorry, I need to have another look to my notes. It's not easy. Okay, yes, correctly observed. In the other video, I talked about the origin of time, and we saw as necessarily time must have had an origin. It cannot have existed since forever, like always existed, because an infinite amount of time can never pass, can never finish. And it must have had a beginning. So we need a timeless phenomenon to produce time. We need a spaceless phenomenon to produce space. So let's go back to the topic, the edge, because we're talking about the edge of the universe, so space, but also time. If we want to consider the edges of a circle, we must consider two dimensions entirely. If we want to consider the edges of a sphere, we must consider three dimensions. If we want to consider the edges of reality of the universe, we must consider three dimensions and time. So, what's at the edge of the universe? The origin of time, which is the timeless and spaceless singularity. But there might be something misleading here, another booby trap. I'm not saying that this is proven science. This channel is a hobby. It's not my scientific channel about nutritional sciences, health, etc. So these are mere speculations and hypotheses. So whatever I say, it's very hypothetical. If it even deserves consideration as a hypothesis. It's just speculation. But hey, I'm tired of keep seeing and seeing and seeing videos and reading scientific articles about things that we already know. We already know those things. We need answers to what we don't know. So, but if we don't know if there are unanswered questions, we don't have the answers. Okay, at least let's try. Let's try to give some answers that at least logically are reasonable, are plausible, and at least seem to be compatible with the things that science has already proven. And then, of course, scientists not only are welcomed, physicists, mathematicians, but they are begged to evaluate these things and to dismiss them or improve them, whatever. Please do. As I said in the first video, I'm trying to throw apples on scientists and geniuses' heads, like the apple that fell on Newton's head stimulated him, inspired him to come out with the gravitational laws and all those beautiful things. The apple itself, it didn't have a big value, but it kind of kick-started his ideas. That's what I'm trying to do. Please, give your contribution. It's a teamwork. So, speaking of which, before the end of the video, I will make a request to mathematicians and physicists. So, as I said, so the origin of time, a timeless thing. One could tell me, well, a timeless, spaceless initial singularity, detached from time, I don't know, I'm not sure. What if before time, we cannot say before time, it doesn't make any sense. Sorry, there cannot be a before time, because it would mean that there's still time before time, but there's not. Okay, let's not use the word before. Let's say pre-time is the same thing. Sorry. Okay, let's say that the initial singularity. Okay, I found it. Some people could object to me, to my hypothesis. Nick, but what if the initial singularity was something, and then some people say quantum fluctuations caused it to change and become time, so that time started? Well, I can say I agree. I'm saying the same thing. So, from one point of view, so I would have objections just about the grammar, the vocabulary that we use to say these, but the pure concept, detached by vocabulary, I could agree. Maybe I'm saying the same thing. Why? I will demonstrate it. The two different theses here are if the initial singularity is something else, it's not space-time, something that is timeless and spaceless. Well, on this we should agree. but it's something else. It's not the very same thing as space-time and the universe. The other theory is that space-time and the universe at that point were the same thing. It's that the initial singularity changed, got transformed, turned into space-time, which started. Verbally, I do not agree with the use of this vocabulary, of this terminology. Why? Because we cannot say that quantum fluctuations, because something to fluctuate, it needs anything to happen needs time. How can something fluctuate and move and start time if time wasn't started yet? Or how can we say before the initial singularity had no time and then it got turned into time, so it somehow fluctuated? How? There was no time, it cannot mutate, and it became space-time. How can I say before there was no time? How can I say it fluctuated? It's a past tense, there was no time. How can I say it turned? There was no time to do anything, to change, to turn into anything else, and turned again, past tense, if there was no time yet. I cannot even say yet. So vocabulary-wise, I would prefer what I used. That's why I used those words. Instead of saying before, I would say timelessly. Instead of using the past tense, it caused time or it became time, I used the present because we don't have a conjugation that is timeless. Such a vocabulary doesn't exist. It's never been, it's not been invented yet. So I said timelessly, the initial timeless singularity, timelessly causes, not caused, time. So clarified that I would need some adjustment to the vocabulary, to the conjugation of the verbs to agree with the other thesis, then maybe the other thesis is saying the same thing. There's just a subtle difference that maybe it's irrelevant because maybe we're just playing with words, but the concept itself is independent. What do I mean? If you say, what if the initial singularity had no time yet, already I don't agree with the word yet, and then it turned and fluctuated and started as a space-time. Wait a second. Wait a second. It had no time, had is wrong again, past tense, implies time, but you are saying, Nick, what if it had no time and then it fluctuated? But again, let's accept it. It had no time, and then it fluctuated, and it produced, caused, turned into space-time. So what if the initial singularity is the universe, space-time, just mutated? Wait a second. You are saying that because it became universe, because it became space-time, it is not anymore how it was before, which means that having become time, its time features, characteristics are gone. So it means that from our point of view, I mean, in time, in space-time reality, it's gone. It's not anymore how it was before. But wait a second. Then what's managing remote region of the universe that cannot interact at all physically because they are beyond the limits of the observable universe? What's grabbing them both and keeping them into existence? Remember the example of the scaffold of the universe, the hidden scaffold? Remember the example of the pillars and foundations holding the house structurally? While in this case, metaphorically speaking, holding means keeping their existence going on, not disappearing into thin air, into nothingness. What's holding them? What's managing their interactions, their existence beyond the reaches of the speed of light? Also, How can it be gone? Gone is a concept that only makes sense in time. But before becoming time, space-time, fluctuating allegedly, it had no time. So the initial singularity as it was, again it can be, was, because it's past tense, but again, let's accept it. Because the initial singularity as it was before causing time had no time, it's still there. It still exists because it's not subject, it doesn't undergo to the flow of time. But we also have space-time that is flowing. See that they are two different things? And we need something that is beyond time to manage the temporal things. We need something that is beyond space to hold and manage the existence and the interactions of space and all its domains. Also, if my hypothesis that whatever is beyond reaches of the physical limits, speed of light, observable universe, and whatever is beyond there, because to get there we would need to overcome the speed of light, whatever is there is to us in the same time or space or both that we would end up if we overcame the speed of light, which means it doesn't exist yet. It's in the Big Bang yet. If this hypothesis of mine is correct, we need the initial timeless singularity to still be there doing its job. So, rather than, and for many other reasons that there's no time to explain, rather than the initial singularity becoming space-time and the universe, I prefer much more, and it makes, at least to me, it makes much more sense to think about space-time, the universe, the temporal reality, and the initial singularity as two different things. Each one doing its own job. Hyperreality, timeless, spaceless, space-time. So, timeless singularity, which is the initial singularity. Timeless action, spaceless action. Temporal, spatial actions and interaction. This is my favorite, one of my favorite way to metaphorically represent reality, the universe, on a bidimensional board or piece of paper. And the request I had, as I mentioned, to mathematicians and to physicists is this. Where did I write it? Sorry, it's a mess here. Okay, if we assume, as I said before, that all around the universe is surrounded by a cosmic singularity-like pseudo wall, like a kind of a black, instead of a black hole wall. And we apply to this model the same math that leads to black holes singularities, only reversed, like kind of reverse engineering the math of the thing. Could we test these hypotheses that I made in this video mathematically? I'm not good at all at math, so I'm asking you, would it be possible? Thank you. And another thing, the other booby trap I mentioned, and then I got lost again, two difficult topics. Let's say the universe and its pseudo for the edge So this is the edge, the possible physical edge, uh, drawn by the limits of the laws of physics, mainly the speed of light and the observable universe. So what is beyond is whatever, as I said, where is beyond, when is beyond, it's where and when we would end up, indeed, if we overcame the speed of light. Indeed, if we could overcome the speed of light, we would have gotten there. So, right now-ish here is in that place, and in that time, we would end up if we crossed the speed of light, if we overcame the speed of light. Because to get there, we need to overcome the speed of light. It seems so logical to me. But it's not possible to overcome the speed of light. Indeed, in my hypothesis, this does not exist yet. That not possible thing is why it doesn't exist. Non-possible to overcome the speed of light, in this case, is a synonym of doesn't exist yet. Doesn't exist, wait a second. It doesn't exist means it's not real from the physical reality point of view. Unreal is synonym of impossible, of not possible. It's so to get there we would need to overcome the speed of light, but it's not possible. It's unreal. Indeed, this doesn't exist yet. Indeed, if it doesn't exist, it's not real. But it doesn't exist yet for us right now, relatively to our frame of reference. But relatively to the frame of reference of something that is within our light cone reach, let's say here, this is covered by the laws of physics. So, wait a second, how is this possible? I didn't think about this even before when I thought about the video and I draw my notes. How is this possible? So right now, this frame of reference is our light cone frame of reference, and it's real, and it's very well scientifically proven. So in our current frame of reference, we have something here near the edge right now, okay? So what this is beyond, it doesn't exist yet for us. But wait a second, because it's back to the origin of the universe. But wait a second, if here it's compatible with us, because it's within reach, this thing that is here, whatever it is for us, has its own edge. So for this thing, this part is real. How comes this is real for us and this is real for it, but how comes this is not real for us? We need a timeless singularity that manages timelessly both. So relatively to us, this part is back to the Big Bang. The Big Bang is a continuous event. It doesn't exist yet. It just started now. Because right now the light would have crossed that edge. Again now and now and now. Every millimeter of 300,000 kilometers or whatever beyond every second. Okay? So relatively to us, this part doesn't exist yet. It just started the Big Bang for them. But we need a universal, absolute, beyond space and time, timeless and spaceless reference point that manages both and that causes both the Big Bangs. Indeed, yes, it is true that for our frame of reference right now, this reality is all physically real and proven, but this is very far from us. And now, to get here, we would need to get at the speed of light almost. So even this is not now, it's in our past. So it exists in space-time, but in our past, not in the now. See the Brian Greene video that I'm gonna put in the description. So see, the farther we go from us, the faster we travel to get there, the more backward in time that thing is, and backward and backward and backward until beyond that we go to the origin of time. It doesn't exist yet. Its Big Bang one just started. It makes sense to me. So if beyond this limit there's the origin of time, there's the Big Bang, there's the origin of time, it means that there's the timeless singularity relative to us. Does it mean that there are many singularities that are all the same, all equal? No, because there's no time, no space, so it cannot even be divided. It's not that there are many singularities that are very similar or equal. It's the same thing. The spaceless and timeless singularity, it's mathematically not possible to be divided. It cannot be divided. So it's not that it's another singularity. It's the same singularity. So it's here, it's here, it's here, it's here, it's here. It's the very, this thing is the same thing as this. But how it's possible? It's in the two different opposite limits of the space. But space makes sense all inside, not outside of space. Outside, there's no space. So there's no locality. We have quantum non-locality even in space, like with the quantum entanglement. Imagine beyond space. It wouldn't be the spaceless singularity if the spatial geometry would still make sense in the spaceless singularity. An interesting thing, on the other hand, is the hypothesis of the multiverse. Many universes, parallel universes. So first of all, we can consider every single frame of physical laws within the light speed of light limit reach, like many different parallel universes. But also, what if the timeless and spaceless singularity produces, or from our point of view is producing, but I prefer to use the simple, produces trillions of other universes? Where would they be? They would be nowhere, because they're not in space. We're talking about different spaces. Maybe there are even other universes that it produces that don't even have a space at all. So if you notice, there is one thing besides the spaceless and timeless singularity, of course, there is one thing that we can master that is beyond, that transcends reality, our reality, space-time, the universe. It's math. Mathematics. For the very, let's pretend, thought experiment, whether there is only one universe or there are many universes, even completely detached from our universe, spatially, temporally, completely different realities with even different laws of physics, whether there is only one universe or there are many other universes, or two or three or four, see, math still applies. Math transcends our universe, because we can say there's only one universe. See, math contains it. There are 3 universes. There are a quadrillion universes. See, math is beyond our universe and reaches them all. So math, if there are other universes, I'm not saying I know that there are, I'm just saying if there are other universes, one thing is sure. For the very fact that they are other, whether there are only 2 more or 3 more or a quintillion more or even more, it's proof, it would be proof that mathematics is in common between all the universes. And that it transcends them. If there are other universes, even with different laws of physics, how many are? A quintillion? A quadrillion? Just only another one? Even if there are different laws of physics, those different laws of physics are still different applications of the same math. Let's say different laws of physics, different constant of universal gravitational constant, but they would still use the same math. Completely different, same math. So the physical application would be different, but the mathematics behind it would still be the same. And it's beyond the spaceless and timeless edges of all these universes. Math goes beyond. You now let me tell something to mathematicians. You should feel honored. I wish I could. You are able to master a trans-universal science, a science that goes beyond even the universe, a science that would even cover and apply to any other crazier universe if there are other universes, no matter how many. You master, at least in part, not the entire math, because math is also a continuously growing science, but you master at least partially, it doesn't matter at what extent, a science that is trans-universal, not intra-universal. It's beyond. It transcends. So, of course, the timeless and spaceless singularity uses math to manage the different domains of our universe that are beyond the light limit, the light speed limit reaches, which means the many Big Bangs, if my hypothesis is correct, and if there are other universes, it uses math to manage them all. And if it's true that math is related to reason, it means that reason as math transcends our universe and applies to other universes, if there are. Even if there aren't, we can say there is only one universe. See, still math contains it. But if there are other universes, as math covers them all and applies to them all, no matter how different their laws of physics are, if they even have physics, if math and reasons are, let's say, two sides of the same coin, or somehow related, it might mean that reason also transcends the universe and would apply to the other universes. Indeed, we are able to reason and speculate about the other universes. But wait a second. It means that the initial singularity also uses reason as a tool, which means that the initial singularity reasons. Maybe it's God. In the beginning, it was the logos. Now I'm remembering. In Greek, logos is reason. And wait a second, we are able to reason about it. We have a reason. Maybe he made man in his likeness, give the ability to reason, even if at a reduced extent. But I don't want to go into metaphysics. I don't want to go off topic. We were talking about the edges of the universe. So anyway, this is it. So if the initial singularity is before time, that doesn't make sense, so it's timeless. Makes sense verbally. Timeless makes more sense than saying before time. And it's spaceless. It means that it's not gone, it's still there. It's still causing Big Bangs. It's still causing Big Bangs. If my hypothesis that what's beyond the edge of the observable or reachable by light universe doesn't exist yet from our point of view, but from the point of view of what's at our edge, it exists. But what's in our edge, relative to now, for us to be at the edge, we would need to jump at the speed of light. So we would jump in the past. The farther we jump near that edge, the farther we go back in the time, beyond that edge, beyond the speed of light, beyond the past time, at the origin of time, Big Bang. That's why I say that there are many Big Bangs all the time. So let's try to conclude, summarize with one sentence. What's at the edge of the universe? The Big Bang. And beyond that, the initial singularity. So where's the edge of the universe? It's nowhere from our point of view. It doesn't exist yet. It's in the past, it's the beginning of time. It's being produced right now and in every second wherever the light can go. So the shorter version of the answer, what's at the edge of the universe? Nothing, because from our point of view, it doesn't exist yet. It dives like a waterfall into the past, all the way back to the origin of time. So what's at the edge of the universe? A kind of a black hole-ish wall, can never be reached, and beyond that, nothing. It doesn't exist. There's no space, no time. Just from a temporal and spatial universal point of view, it doesn't exist. It's nothing. It's not being created yet. From an absolute point of view of the spaceless and timeless singularity, there's the spaceless and timeless singularity that is just going to produce a Big Bang. That's my hypothesis. Thank you so much for your timeless patience, and I hope you enjoyed.